Here's your bell ringer for the day. So get out a calculator and work through these, please. If you could pause the video for a few minutes and give the students a chance to work through this, that would be excellent. This one on the left is a permutation, okay? So we're gonna have to use that permutation button in our calculator. It'll be 10p4. And when you do that, you will get 5,040. Okay, so that's just practice using your calculator for that one. And then when we do the other one, that's a combination, so it's 15 choose 5, so that is 3,003. Okay, so that's just some quick practice using your calculator. Down here below, you want to try this without a calculator. Okay, so we have 12 factorial over 12 minus 4 factorial times 4 factorial. So this right here will go to an 8 factorial. So on the bottom, we'll have 8 factorial times 4 factorial. So remember in class, we kind of broke this down. So it's a 12 times 11 times 10 times 9 times 8. And we knew that that 8 was going to continue on forever. And we just wrote it as, or not forever, continue on to a 1. Okay, and we knew that we had an 8 factorial on the bottom that we can use to cancel that one out, right? And so we had, and we could write that as 4 factorial or just expand it 4 times 3 times 2 times 1. So we did that so that 8 factorial canceled out. And then we pretty much looked to cancel out between the bottom and the top, the numerator and denominator, with the bigger numbers. So that 4 could cancel with that 12 and make that 12 into a 3. That 3 can cancel with that 9 and turn the 9 into a 3. And the 2 could cancel with the 10 to turn the 10 into a 5. And then we just multiplied from left to right from what we had. So it'd be 3 times 11 is 33 times 5 times 3 is 495. Okay, if you recognize this right here, that is a formula for a combination, which you could also verify this. You could put this in your calculator as it is here, right? You could just throw that in your calculator. You got to make sure that you put the entire bottom in parentheses, or you could do 12 choose 4 because that is the combination that you're looking at right there. Okay, and you get 495. So the next thing we're looking at is your homework, and I'm just going to work through a few of these so that you can see some ones that I assume that you might have some questions on. Remember that we only need to do evens on these, so those are going to be the ones that I'm looking at, and this should be the back page, your probability 3. If we want the exact page, it should be, let's scroll down there, that should be page 714. So at the end of class, we kind of ran out of time, and the ones I wanted to look at for sure were a couple of these on the top, because these are the probabilities of these events when we're using the combinations, because you're looking to get those options with one draw. So for the first one here, you're going to have the probability of getting 1 red and 1 yellow. So you first have to say how many reds do you got and how many yellows do you got, and then at the end we're going to look at how many total we have. So to get that 1 red, we have a group of 4, so it's going to be 4 choose 1 for that 1 red, and then we're going to take that and multiply it by 5 choose 1 for the yellows. So we want 1 red here, 1 red yellow, or excuse me, 1 yellow here, and then we're going to divide that by the total that we have completely. So we got 1 green, 4 red, and 5 yellow, so that's going to be 10. So we'll have 10, and we're choosing 2. Okay? So then you'll go ahead and put that in your calculator and see what you get for an answer. So 4 choose 1 is just 4, and 5 choose 1 is just 5. So 4 times 5 is 20. You'll have 20 on the top. And then we got 10 choose 2 on the bottom, so that's 45. So 20 out of 45 gives you 0.44. Okay, and we could have left it as 20 out of 45 and simplified it down. If we leave it as 0.444, that's about 44%, okay? Either way you would like to express that, it's not specified exactly how you want to do it, okay? Number 6 is just like number 2, so I shouldn't have to do that one. This one's kind of interesting because it's the probability of getting 2 green. Now, if you look at how many you have, you only got 1 green. So it is not possible to do that one because there's not 2 green for you to choose. All right. Now, if I compare this section to this section down here, it's pretty much the same thing. So you'd be doing 8, 10, and 12 the same way. Okay, 8's probably the easy one out of the group here because you're only looking at one group. So we have 2 dimes, so we're going to have 4 choose 2 for the dimes, so that would be us getting our 2 dimes, and then we have 3 plus 8 plus 4 plus 10, so that's going to be 25. So we'll have 25 choose 2. That would be our total possibilities down here. So if you put those in your calculator, see what you get. So 4 choose 2 gets me a 6 in the numerator. 25 choose 2 gets me to a 300 in the denominator. So 6 out of 300 is 1/50th. Okay? Or if we just put that in our calculator, you get 0.02, which is a 2% chance to get that. Okay? That should be enough for you to finish those first 2 sections. We'll look at some of these down here, okay? And that one looks like it's about the same here. So 14 and 16 should be pretty much the same as what we did above. And then let's look at some of the ones down here. So let's look at number 18. Okay, so for exercises 17 through 20, we're looking specifically at, it should be 17 through 19. Use the table that shows the range of verbal SAT scores for freshmen at a small liberal arts college. If a freshman student is chosen at random, find each probability, expressed as decimals rounded to the nearest 1,000. Okay, so if we're looking for the probability of that range, so 550 to 559, we find on our table right there. So you'll have 602 students in that category, and we got to figure out the total number of students. So then you would just add all those together. So 602 plus 129 plus 275 plus 438 plus 620 plus 412. So your total amount of students would be 122,213. And you just simply divide the two. 602 divided by that answer. And we have 0.0049. It says expressed as decimals rounded to the nearest thousandth. So this would be tens, hundred, thousands. So we got to round that 4 up. Okay, so it'd be 0.005. That would be our probability for that one. Okay, I'll just give you a quick review here of the odds of an event, and then we'll jump to the next worksheet quick. So if I have 4 out of 11, remember this is a probability, so we want to change the probability to the odds. So 4 is going to be our successes, right? So 4 is what we want. That's the number of things we want. And then on the bottom is going to be the total. So we don't want the total when we're doing odds. We want the things that we want compared to the things that we don't want. So we take the 4 away from the 11, which would give us a 7. So the odds for number 20 would be 4 to 7, because you just subtract that from the 11, okay? And that should give you enough information to finish the rest of these if you forgot. So 28, you have 2 to 23. So remember, 2 is the number of things we want, and in this case, 23 is the number of things we don't want. So our probability is going to be 2, and we have to have our total, so we add those together, 2 out of 25. So that's the probability for those. The odds were not too bad yesterday. Second worksheet. So this one should seem a little bit more familiar to things that you've done before because there's no combinations and permutations involved. So we had to do evens on these as well. All right, so a die is rolled 3 times. Find each probability. So we're starting with number 2 here, the probability of getting no 4s. So that means we need the probability of getting things that are not a 4. All right, so we got numbers 1 through 6. So that's 1, 2, 3, 4, 5, 6. For each roll, if we don't want a 4, you're going to have 5 options. So we're rolling 3 times, so it'll be 5 out of 6 times 5 out of 6 times 5 out of 6. And then that would be your probability. So 5 times 5 is 25, times 5 is 125. And then 6 times 6 times 6, I think, is 216. So 125 out of 216. That would be okay. You could try to reduce that if you want to, which it doesn't. Okay, so you can just leave it like that if you want to. For number 4, you want 3 different even numbers. So remember, we're rolling it 3 times. So to get those even numbers, that's a 2, 4, or a 6. So for the first roll, you're going to have 3 out of 6, right? And for the second roll, we're down to 2 of those even numbers because we want either a 4 or a 6. Say we got a 2 to start out with. And for the third one, we only have 1 option to get that even number. And we have to keep that 6 on the bottom because there's always 6 options whenever you roll your dice. You can't change that option. So it's going to be 6 out of 216, which is 1 out of 36. Okay? So number 6 is kind of similar to that one, but you would have an even number, which is 3 out of 6, an odd number, which is 2 out of 6, and a 1, which is 1 out of 6, and you multiply those probabilities. Okay? So down here, the next one is kind of similar to the dice, but you have nickels, dimes, and quarters. Okay, so let's, like number 8, you would have a nickel, pick a nickel, then a dime, then a quarter, if replacement occurs. So when replacement occurs, that means that that bottom number, your denominator, stays the same. Okay, and then for no replacement, which looks like you don't have one in this section, that number would go down by 1 each time. So for this one right here, you can end up getting the answer when you're done. But it'd be 3 out of, so 5, 10. 3 out of 10 for the nickel, and then 2 out of 10 for the dime, and then 5 out of 10 for the quarter. And that bottom number stays at 10 the entire time because replacement is occurring. Okay? If there is no replacement, then that number would drop by 1 each time. All right? So down here, number 12 and 14. So for 12 and 13, it just says determine if it's independent or dependent. So remember, independent events, you're going to maintain the same number each time. You're not going to take out something for a successive event. And dependent would be like if you take one out and don't put it back. Okay? So go ahead and see if you can figure those out. And then 14, we can finish with that one. So the Fadivas are planning a 3-day vacation to the mountains. A long-range forecast reports the probability of rain each day is 10%. Assuming the daily probabilities of rain are independent, what is the probability that there is no rain on the first 2 days, but that it rains on the 3rd day? Okay, so we would have day 1, day 2, day 3, and I'll write the probabilities below for each one of those. So the probability of no rain, remember, if our probability of rain is 10%, that the probability of no rain would be 90%. So day 1, we want no rain, and day 2, we want no rain. So the probability of both of those is 90%. And then the probability of rain is 10% on the 3rd day. So you would just multiply those percentages to get your final percent of a 0.081. Okay, so it'd be an 8% chance that that's going to happen. And then down here, you should try that one out, see if you can get that. All right, so that's your worksheet. Make sure your name is on that and turn that in and get yourself ready to go for this lesson. Okay, so please pause the video while students are turning in their worksheet. Remember, if you guys don't turn it in right now, that it needs to be done by the end of the class period. All right, so probability 5, we're talking about adding probabilities now. So some terminology you're going to see is mutually exclusive and inclusive when we get to them, but you're going to see that word there. You're going to see or quite a bit in these probabilities, okay? So we're going to jump ahead. Actually, we can look at this one right here. So what's the probability of picking an ace, king, or queen in a standard deck of playing cards? So remember, standard decks, 52 cards. And then we got to think about the probability of getting each one of those. So we want an ace, king, or queen. So here's that word that I just said that we want to pay attention to. When we're talking or, that's when we're going to add probabilities, which I'll show you again on the next slide. Okay? So the probability of an ace, there's only 4 of them. Okay, 4 out of 52. All right, and then we leave that bottom number alone. So a king is 4 out of 52, and then a queen is 4 out of 52. So since we're talking or, the probability of getting one or the other, you'd have 4 out of 52 plus 4 out of 52 plus 4 out of 52, which gets you 4, 8, 12. So that's 12 out of 52, which you would then reduce down. So we can take a 2 out, and that gets me to 6 out of 26. We could take another 2 out, gets me 3 out of 13. Okay, so the probability of getting one of those is 3 out of 13. All right, so that's where we're talking about mutually exclusive events. So when we have something like this where it's a probability of A or B, we're going to add those probabilities together. Okay, so you find the probability of one and the probability of another event, and you add those two probabilities together. So go ahead and write that down, and then we'll look at the first example here. All right, suppose a card is drawn from a standard deck of 52 cards. What's the probability of drawing an ace or a king? Well, that one should be fairly simple just because we took care of one just like that. Probability of getting an ace is a 4. Probability of getting a king is a 4. Well, it's 4 out of 52, excuse me. And the probability of a king is a 4 out of 52. So you just go ahead and add those probabilities. So we get an 8 out of 52. And then just like the last one, we took a 2 out twice, or we could take a 4 out. You will get a 2 out of 13 if we take a 4 out. All right, and you can put the 8 out of 52 in your calculator and let it do the work for you if you want. Okay, so you'd have 8 cards out of 52 if you wanted a visual. Okay, so another fairly simple one. So what's the probability of selecting a blue or white marble from a bag containing 5 blue, 2 red, and 3 white marbles? So this is what we're looking at here. Probability of a blue or white, okay? So probability of blue or white. And if we're following that little box that we had on the last one, this turns into the probability of blue plus the probability of white. You good? Mm-hmm. All right, so probability of blue and probability of white. So we look at the blue marbles. We got 5, so 5 blue marbles out of 10 total. And then we got 3 white out of 10 total. Add those together, and we're going to have 8 out of 10. And you want to reduce these fractions so we can take a 2 out to get 4 out of 5. So that's our probability of getting a blue or white marble from this bag of marbles. So let's look at this one. See if you can figure this one out. So go ahead, read through it, and then pause the video for a second, and then come back to the video and we'll talk through the solution. So what is the probability of drawing 2 face cards or 2 5s from a standard deck of cards? So you need to think about how many cards that's going to be. So face cards would be king, queen, or jack, because they have the characters on them. They're the face cards. Okay, and then 2 5s. So probability of getting those face cards, 2 face cards or 2 5s from a standard deck of cards. So our 5s, how many 5s do we have? There are 4 of those. Okay, so there's 4 of each of one of these. And then the 5, we got 4 of those. Okay, so we want the probability of 2 face cards or 2 5s. So then we can set that up. Probability of 2 face cards plus probability of 2 5s, and then we can go from there. So we have to kind of think about this a little bit because we have 2 face cards, so we're picking 2 cards here. So out of our total face cards right now at the beginning, so that's this group right here, there's 12 out of 52. Okay, and then we're gonna keep that card, right? So we're taking those cards, we're drawing all of these cards. So 12 out of 52 for the first one, and then we're gonna have 11 out of 51 for the next one. And then, so these are 2 separate things. So then we want the probability of 2 5s, okay? So when we do that, so our first poll will be 4 out of 52, and then the second one will be 4 out of 51. Okay, because we have to treat these as if we were just doing those probabilities. That's the way these work. All right, because it's not going to be 52, 51, 50, 49, just because we're not doing it all at once, the way the probabilities work out. So we'll take these 2 plus these 2. All right, and we have to multiply on those because we're pulling 2 cards for each of those probabilities, right? Because we want the probability of the 2 face cards or the 2 5s. So we want the 2 draws of the face cards or the 2 draws of the 5s. And that's why we only have 52, 51 for each one, because they're 2 separate events. All right, so then we'll go ahead and calculate that. Put those fractions in your calculator to see what you get. The one on the left, you get 33 out of 663. On the right, we get 3 out of 663. And then when you go ahead and add those, you're going to have 36 out of 663, which will reduce down, so you can take out a 3 on both of those. Or
Attention FFA members, there will be a meeting in the North Lobby. Freshmen and sophomores, your meeting will start at 3, and juniors and seniors, yours will be at 3:15. Thank you.
Or your calculator will go ahead and simplify that down for you to 12 out of 221, which you can then turn that into a percentage if you want to. So it's 0.0543, which is 5.4%. Okay, so kind of a harder problem, but if you set it up like this, where I want one or the other, and now I turn it into something I've seen before, so I can do those. I've done something like this yesterday, I've done something like that yesterday, and then I just kind of follow the routine to find the probabilities. All right. So let's go ahead and try this one now. All right, so go ahead and pause the video again and we'll try this one. It works out just like the last one. All right, so we want to find, if he randomly selects 2, find the probability he selects 2 baseball cards or 2 basketball cards. So it'll work out the same as the last one. So we want the probability of 2 baseball cards or 2 basketball cards. So then we can split that up because it's a or. So it's a probability of 2 baseball plus the probability of 2 basketball cards. Okay, so my 2 baseball cards, so that's going to be how many baseball cards we have. So 4 out of 7 for my first pick, and then 3 out of 6 for the second one. So that takes care of the baseball probability. Or 2 basketball cards, so we have 3 basketball cards, 7 total, and then that'll go down by 1 since we picked those cards. So it'll work just the same as the last time. And if you're using your calculator to simplify this stuff down, this turns into 12 out of 42 plus 6 out of 42. And then that will get you 18 out of 42. And then just reduce it down to 3 out of 7. Okay, so let's jump ahead to a couple other ones here, and then we'll see. So we're going to look at the separate kind here. So these are called inclusive events. And this is when we have things that overlap in the 2 events. So this is the overlapping piece, and I'll show you what I mean by overlapping. Okay, or you could probably read the probability here, number 7, and you can figure out what we mean by overlapping. Okay, so go ahead and write that down, pause the video if you need to, and then we're looking at this example. So what is the probability of drawing an even number or a multiple of 3 given cards numbered 1 through 20? Okay, so we want probability of even or a multiple of 3. So the reason that we have that probability of A and B in the back there, we're subtracting, is because we know that some even numbers are multiples of 3. So this would be the probability of an even number plus the probability of getting a multiple of 3 minus the probability of even and a multiple of 3. Okay, because that's the overlap there that we want to take care of. So the way we're going to take care of this one is we're going to write out 1 through 20. And then we're going to see the overlap there. All right, so go ahead and write out 1 through 20. We're going to find the probability of getting an even number. Okay, so let's circle all the even numbers here so we can kind of get a good idea. So we got 2, 4, 6, 8, 10. Let's go backwards. We got 20, 18, 16, 14, 12. So out of the 20 numbers, we have 2, 4, 6, 8, 10 evens. So probability of getting an even number is 10 out of 20. Okay, and then we want to get the probability of a multiple of 3. So that would be 3, 6, 9, 12, 15, and 18. So the multiples of 3, we have 2, 4, 6 of them. So 6 out of 20. Okay, and now you can see the ones that overlap. How many we have overlap that are even and multiples of 3. So the ones that I have a red and black circle around, they're 6, 12, and 18. So we have 3 of them out of 20 that are those overlapping ones. So you see why we have to take care of that, the overlapping events there, those inclusive events. All right, so let's go ahead and add these together. So 10 out of 20 plus 6 out of 20 is 16 out of 20. Okay, 16 out of 20 minus 3 out of 20 is 13 out of 20. Okay, so that would be your probability, and you can see hopefully why we have to do this part. You have to take into account any kind of overlap on the numbers. Okay, let's look at another one that has some overlap. So what's the probability of drawing 2 red cards or 2 face cards from a standard deck of cards? Okay, so we need to figure out how many of each we have and which ones are going to overlap. So we have, let's write that out. So we have probability of 2 red or 2 face cards. So if you're thinking about the ones that are going to overlap here, would be the red face cards, right? So we'll have the probability of 2 red plus probability of 2 face cards minus probability of red face cards. Okay, so it's a red card that is a face card. So see if you can get these probabilities and see if you can get your final answer. So you can pause the video here and figure those out. So to get the probability of the 2 red cards, we're picking 2 cards, right? So we know half the deck is red, so that's 26 out of 52. And we're picking a second card, so that would be 25 out of 51. That's going to take care of that first probability. The second probability, face cards. Well, that's Jack, Queen, and King, right? There's 4 of those for each of the 4 suits. So that means there's 12. So 12 out of 52 cards times 11 out of 51 cards. So we're picking 2 cards again. Minus, we want the red face cards. So of those face cards, half of them are going to be red. So it'll be 6 out of 52 times 5 out of 51. So you're going to have to use your calculator a little bit. If you didn't already, that's the way we set those up. Okay? So multiplying these 2 fractions for this one right here, if you just put it in your calculator, it's okay if you keep the decimals until the end, that's fine. I'm going to have fractions up here for you. So it's 650 over 2,652 plus, we got 132 out of 2,652. And then over here, we're going to have 30 out of 2,652. So those just came from multiplying those fractions. And when we add and subtract our fractions here, we'll end up getting 752 out of 2,652, which we can put that in our calculator, and we get about 0.284. And remember how to change that to a percentage. Move the decimal place over twice, you get 28.4%. Okay? Now let's take a look at one more. So the probability of rain on a Saturday is 30%, and the probability of rain on Sunday is 40%. Find the probability it rains on Saturday or Sunday. Okay? So I'm not going to stop the video. I'll just start working through this one. That way you can kind of follow along. We want the probability of rain. So let's say rain on Saturday or rain on Sunday. Okay, capital S's, right? That's going to be broken down to the probability of rain on Saturday plus the probability of rain on Sunday. So we could have it rain on both days. That's the overlap. So probability of, so minus the probability, so minus the probability of rain on Saturday and Sunday. Right, we don't want it to rain both days. So we have to take that out, that possibility of that happening on both days. So we got some easy percentages to use here, so there's not a whole lot of thought process from here. The rain on Saturday, it would be a 30% chance, so use 0.3. Rain on Sunday, 40% chance, so that's 0.4, so add plus 0.4. And then both, so it's the probability of rain on Saturday and Sunday. So when we see and, we know we're multiplying the probabilities, so it'd be 0.30 times 0.40, and then we can go ahead and figure out what that is. Okay, so go ahead and use your calculator. Do 0.3 plus 0.4 minus 0.3 times 0.4, and you should get 0.58, which tells me that it's a 58% chance that it's going to rain on one or the other. Okay? So hopefully these probability questions make sense. I'll put the answer key for your worksheets and such in Google Classroom. But this is what you need to do for the remainder of the class period. So you have a practice quiz that you'll be given, and then there's a review worksheet as well. Okay? I would start with the review worksheet, the probability review worksheet, because that's going to help you for the practice quiz. So this is what it's going to look like on Monday. Your quiz will be very similar to that, but if you understand both of these, you should be good to go. All right? So the rest of the class period is yours to work on that. These are both due on Monday. All right? So you want to make sure that you're working on these in class. All right? So I hope you all have a good weekend. Thanks for watching.